Hi folks, it's Mr. Moodlage here with another video. This time we're looking at properties of the inverse function, so lesson number 8. Here, continue our discussion from the inverse function before. We're just expanding on this and looking at how can I make it so that my inverse function is in fact a function, right? Because as we saw before in the previous lesson, sometimes it's the case that when I take the inverse of my regular function, let's say the quadratic function or a parabola, well, it could be the case that my inverse function is not a function, it's a relation. So how can I make it so that it is a function? Well, let's start with an example here. I have the square root, so I have y is equal to the square root, y is equal to 2 times the square root of x minus 1, and then outside the square root I have plus 4. So I want to find the inverse of this, and then sketch the inverse, and also mention the domain and range of the inverse equation, right? So here, let's say I'm going to start by swapping my x and y. So I'm going to say x is equal to 2 square root y minus 1 plus 4, just like this. I'm going to subtract 4 from both sides, and then divide by 2 to get square root of y minus 1. I'm going to square both sides now, and then add 1 after that at the end. So I get y is equal to this. So my inverse function is just this right here, the y minus 4 over 2 squared plus 1, right? Now, this is a quadratic function right here. I can go ahead and graph this, or I could just make note of the fact that, I can make my table right here, and then have my parent function right here. So this is the positive square root, right? You got to just be very mindful of this. This is the positive square root, not plus minus, since it's written for me and there's nothing there. By default, it's positive. So hence, right, the function is going to be 0, 0. The parent points, key points 1, 1, and 4, 2. Those 3 points are sufficient. And then I'm going to apply the transformations here to that parent function, right? If I'm doing mapping points. Otherwise, I could have went ahead and just graphed this. But again, I want to be mindful of the fact that, well, in this function, for it to be a function, well, that is going to be a function, but it's only going to be the positive leg of that, right? So this pink curve right here. But how did I get that? Well, I'm just going back to mapping points, looking at the parent function, and then looking at the transformations for that. So the mapping points right here. So x, I can look back to the original transform function right here. It looks like there's like a horizontal translation, 1 unit to the right, so plus 1 for x. And then for the vertical direction, there's a multiplication of 2, and then an addition of 4 units up. So each of my x values, I do 0 plus 1 to get that, and then 1 plus 1 to get this, 4 plus 1 to get that. So that's really my new x coordinates. My y coordinates would be 0 would get doubled and then add 4, so I get this. 1 would get doubled and then add to 4 to get 6. 2 would get doubled and then added to 4 to get 8. So those are the transformed points, and then I can go ahead and now find the inverse of that, which would be swapping the x and y's here. So swapping these points right here. So 4, 1, right? Swap the x and y's here. So 6, 2, and then 8, 5, as we could see here. So these are the points that I want to plot on my function, on my grid right here. So 4, 1 would be here, right? 6, 2 would be here, and then 8, 5 would be here. That would be the inverse function. I have the parent function, which is the coordinates that I started with right here, those 3 dots. And I have the transform function is here, intermediate step right there, and this is the reflection line y equals x, right? So you can see clearly there. In terms of the domain and range of the inverse equation, so that's right here, it's going to be the flipped version of the domain and range of my parent function, right? No, sorry, not the parent function, of the transformed function right here, f of x. So if the domain of f of x is x such that x larger than 1, the range of this is going to be y larger than 1, larger or equal to 1. If the range of f of x is y is greater or equal to 4, the domain of this is going to be x is larger or equal to 4, as we could see here. So that's what that looks like. That's why it's only larger or equal to 4. That's why it's only the right leg because this is the positive part right there, positive square root, hence this is the right leg of that. That's what makes that a perfect reflection. Are both functions or both relations functions? Yes, they are, because they both pass the vertical line test, right? This function, if I did the vertical line test, it would pass. This function, the inverse function, if I did the vertical line test on that, it would pass, right? Individually looking at them. From the last lesson, we know that the inverse of y equals x squared is not a function, since it includes both branches, square root of x and square root of negative x. But the individual branches are functions, right? If I give it to you like this, y is equal to square root x squared, then, you would see that that would be a parabola like this. The inverse of this would be like the sideways parabola, and that would not be a function because it would fail the vertical line test, right? But the individual branches are. But so conclusion, the inverse of a function is not necessarily a function, yes. If you're asked for the inverse function, you may have to restrict the domain of the original, so chop off a branch, either left side or right side, which in turn restricts the range of the inverse, which would make it a function. Right? Good. Okay. So let's take a look at an example here. I have a function right here. It's a quadratic function. F of x is equal to x minus 3 squared minus 6. That's a quadratic in vertex form right here. Notice the a value is 1, so it opens up. And then remember, step pattern 1, 3, 5. If I wanted to graph f of x, I just put a dot at the vertex right here, 3, negative 6. And then I just use, 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, 1 right, 7 up. But you get the idea. And then 1 left, 1 up, 1 left, 3 up, 1 left, 5 up, 1 left, 7 up, like that. And then you get the quadratic function right there. So that's f of x. The inverse, I'm just going to take those points, right? So this is going to be what? 3, negative 6. So it's going to be negative 6, 3 right here. And I would do that for the other points as well. Just swap the points, right? Like take any point. So that would be what? 5, negative 2. So it would be negative 2, 5 right here. And then just connect the dots like that, right? Good. So that's how we can do that. Are both f of x and its inverse functions? Well, f of x is a function, but the inverse is not, right? The inverse is not a function because it fails the vertical line test. We want to state the domain and range of the function, the original function right here. That's this one right here. Well, in the x direction, it goes on forever. So x is an element of real numbers. In the y direction, it looks like y has to be bigger. So it's an element of real numbers, but y has to be bigger or equal to negative 6. Like this. Now for the inverse, notice the swap right here, right? The domain of my original becomes the range of my inverse, right? The domain here becomes this range right here. So x element r becomes y element r. Y element r such that y greater than negative 6 becomes x element r such that x greater than negative 6, right? Because this right here, the range of that becomes the domain of this when it's flipped. Okay, good. Find the equation of its inverse. Again, I'm going to use that technique for finding the inverse. I set f of x equal to y here, and then I switch the sign, swap x and y. So that's what that does right there. I want to denote that. So it's coming up with a new equation. So x is equal to y minus 3 in brackets squared minus 6. And then now I'm slowly isolating for y. I'm going to add 6 to both sides, then I'm going to square root both sides. Since I introduced the square root, I have to put plus minus, and then I add 3, and I get this. So notice the plus minus means I have both the top part of that function and the bottom part of that function, which is, what makes this not a function because I have two branches there. All right. Now this part right here is interesting. It's restrict the domain of the original. So this f of x, so that to make the inverse a function, right? So I have two options here. I can either pick the right side, which is x larger or equal to positive 3, right? So that side right there highlighted in green, which would in fact give me a y larger or equal to 3 for the inverse. So that green line right there that we could see and highlighted as well, and that would be a function. So that's what this represents. Or if I wanted to, I could take the left side. If I took the left side, I would get the bottom part right here. So the left side would be x is smaller in the original function. It would be x is smaller or equal to 3, which would correspond to y smaller or equal to 3 in the inverse, which is what, and then that would give me a function as well. So like this. And that's it. I have another question right here, another example. So if I have this function right here, it's a very good idea to sketch these just on the side to see like what is going on here. But even before that, if we're looking at finding the inverse equation, well, here I'm swapping x and y again, and I get something like this, and then I isolate for y, so I get something like this, okay? Again, I don't have to graph this in this situation, but I'm asked to restrict the domain of f of x so that its inverse is a function. Then it's helpful to note what this looks like on a sketch. So it's a quadratic in vertex form. So I just need to denote like roughly where the vertices are. So positive 2, 7, that would be here, and it's opening up, okay? When I reflect it on this line right here, roughly, the inverse is going to look like this, right? It's going to be sideways. And to make this, right now it's not a function, but to make it a function, I want to make use of this top part or the bottom part. So if I want to make use of the top part, well, then I'm going to pick, well, right now it's y is bigger than 2, right? That top part. Then this would have to be x is greater than 2. So there we go. That's one restriction I can make to the parent function. So, for the original function right there. So x is element r such that x larger or equal to 2 would correspond to y element r such that y is equal to or greater than or equal to 2. And that would get that positive top leg right there, that top half. If I wanted the bottom half, well, then that's y is less than or equal to 2, which would correspond to x is less than or equal to 2. So right as we have there. So 2 answers. You don't have to give both. You would just give one or the other, and they would be either one would be correct. Okay, cool. That's it for that. This is the homework for this lesson, properties of inverses. So you're doing questions 3A, B from the handout, 4B, C, 5, and 6, the ones that are highlighted. Go ahead, give these a go. Here you're like, for each relation, you're following those instructions. Here for number 4, even if the graph of, like when you're asked to determine the function, you're trying to note here, okay, what type of function does this remind you of? Well, it's like the parent function looks like a quadratic. Okay, so it even says parabola here. Okay, so now you're just going to look at, well, this looks like the vertex, and then make use of the step pattern, right, for parabola. So it goes 1, 1, so that's good, and then 1, 3, and then 1, 5, and that's how you know that the a value is 1. And then you could just put, you could just rewrite this kind of, in this case right here, this would be f of x is equal to, well, a is 1, so then you just have the vertex in vertex form. This would be -3, so it would be x plus 3 squared, and then minus 2. Right, so that would give the entire parabola like this as well, but we want to restrict this. We want to say x is an element of real numbers such that x is smaller or equal to -3. Right, and that's what gives us the proper left side of that parabola with that restriction right there. Okay, so that's how that works, and so on and so forth. Go ahead, give those a try, and thanks, and have a great day.